Alright, welcome everyone. In this video we're going to be talking about centripetal forces part 3. Centripetal force part 3. Alright, so in this video we're going to be addressing specifically vertical motion, because in the previous one we talked about horizontal. So now for this one, imagine you are swinging a bucket in a circular motion. Right? So you're swinging a bucket in a circular motion, and it goes at the top, it goes to the bottom. It's attached to a rope. Let's make the rope a different color, right? It's attached to a rope. Okay, and now the problem asks you to, number one, calculate tension in rope at the top and at the bottom. Okay, and part 2 is where is the most tension. Alright, now where is the most tension can kind of be interpreted as, where is the most force exerted on the rope. So have you ever tried swinging a bucket or anything, and then so if not, try it during one of these days, and you actually feel, so close your eyes, and as you move it, try to feel where your hand is being pulled the hardest. Is it at the top as you're approaching the top, or is it approaching as you are approaching the bottom? You'll realize that is as you're actually approaching the bottom. So this will be bottom, and we will prove it mathematically right now. All right, so tension. All right, first thing we got to do is draw a free body diagram, like always. So here we have always our force, centripetal force, going inward. Now this is tension. So for different problems where you're going to have cars coming in, making a loop, etc., this tension is actually going to be normal force and so on. It changes what's making you go in the centripetal force. So for example, our previous video, that force was actually friction, right? So the force changes depending on what it is. So now here you also have gravity, right? mg going downward. So here you have tension going towards the center, gravity again going downwards. All right, so now based on that, let's do the top part. All right, so now let's go ahead and do that. So we're gonna do at the top, you're going to do sum of the forces equals to mv squared over r, right? So if you don't remember where this came from, I would suggest just look at our past video to see how we derived it. It's just Newton's second law, but for centripetal force. Now, what are the forces acting on the body at the top? Well, mg and t are going in the same direction, right? Towards the center. So I'm going to say going towards the center is positive. All right, so going towards center is positive. Okay. All right, so now that's going to be t plus mg equals to mv squared over r. Now this is a vector, not, final. Now, okay, now, actually I'm going to leave that notation out. Okay, over r, velocity. Now, how can we find tension? Well, just, doing a little bit of algebra here. Minus mg, this gives you your tension, right? So that's tension at the top. So now let's compare this with tension at the bottom, which is the second part. Now tension at the bottom. All right, again, sum of the forces equals mv squared over r, right? Now, what are the forces? It's t minus mg. And you may be wondering why. Well, it's just because tension is going in. Remember, I said going in is positive. going out of the circle is negative. In this case, mg is going out of the circle, so it's negative. It's opposing our tension, our centripetal force. So it's negative mg equals to mv squared over r. Again, isolate t, mv squared over r plus mg. All right, and there we have it. So tension at the bottom is actually your centripetal force plus your gravity plus your force of weight. Here, on the other hand, is just your centripetal minus mg, right? So now, that's your formulas. Those are your formulas. I just wanted to point out something really interesting. Some problems will tell you what is the velocity or something that you can be at the top. So usually at the top, if it barely makes it, barely just makes it, the wording can be different. That means that t at top is going to be equals to 0. So actually, that means that your top right here is going to be 0. So then if you do the math, you end up having your velocity, your minimum velocity, which you can cross a circle at the top, has to be square root of gr. I'm just giving you guys the formulas so you can plug and chug, because you don't need to know the derivations for non-algebra, for non-calculus physics. So v at the top is this in order for it to make the loop without falling, and v at the bottom before it enters the curve or whatever it's going, if it's just making it, it's going to be square root of 5gr. You guys can look up the derivations and just let me know if you want me to explain it here. But honestly, I just think you just need to know these formulas for whenever you're asked what's the minimum velocity at the top that it must have in order for it to make the circle or the loop completely, and at what velocity must it come from the bottom, or what is the tension if they give you velocity and the radius at the top and at the bottom. I think that's the most useful things. I'm not going to confuse you with all the math.